scattered between 4,000 and 4,400 feet, and those cloud decks are about 200 feet thick. Weather at the runway end of the pad essentially out of the east at about 10 knots. So KSC weather is go. There is a discussion about the wind at White Sands at Northrop Strip. The weather at this time is within parameters. However, as the window wears on today, they do expect the winds to increase there, and by 2 o'clock this afternoon, then they would expect that the winds would be out of tolerance. White Sands would be used in the event of an abort once around. Among the turnaround activities over the past week has been the removal of the batteries from the Hubble Space Telescope, and we will show you a video now of the activity surrounding the batteries. Here they have just been removed from the payload changeout room and have been placed on transportation carts to be taken down the elevators of the fixed service structure and taken to an awaiting truck for transportation to the battery lab, which is located in the vehicle assembly building. This occurred last Saturday night.
What's that, Jerry?
Each set of batteries, there are two, there are 6 batteries in each set, and the set weighs about 400 pounds. This is the removal of the batteries from the payload changeout room and heading toward the elevators. This decision was made because the batteries can be charged in a colder environment in the battery lab than they can in the telescope on board Discovery. If these batteries are dropped to a temperature of 32 degrees Fahrenheit, then they will take on a charge very readily, and we would get more charge than we could get in the payload changeout room. We can supply a purge to the batteries of about 45 degrees while they're in the telescope in the payload bay, but if they're taken to the battery lab, then they can be dropped to freezing, where nickel hydrogen batteries charge easily and a full charge could be obtained, where in the time available probably not a full charge could be obtained at the pad under a 45-degree purge. The bottom line is that this gives us an extra day of contingency should we need it. We would have launch attempts through Saturday as far as Hubble Space Telescope is concerned, so as compared to our first launch attempt where we had 4 days, with our batteries now fully charged, we have 5. The batteries are a bridge between disconnecting the HST to orbiter umbilicals for deployment and the time that the solar panels are actually deployed on the telescope. Batteries also supply power while the telescope is in eclipse on the dark side of the Earth. This is the transfer aisle of the vehicle assembly building, and here you can see the truck arriving with the batteries for transportation to the lab.
Go ahead. Stand by to perform candle leak check. Yes, sir. Okay, panel L2A1. Go ahead.
There's nothing unusual about the truck in which they're transported. It's a standard delivery truck.
And we're configured now. UDL. I can verify 650. Okay, you can perform your crew module for initial cabin 2 PSI leak check. Proceed with 45. UDL.
Copy. Roaming is TMCC over on 143.
Total charge time on the batteries while they were in the battery lab was 130 hours.
Cabin pressure. And CDR should notify ECL cabin pressure master alarm. the high cabin K-rate.
Yeah, CDR, you copy that?
The payload bay doors of Discovery were closed during the battery charging activity to
Copy that.
provide a very clean environment for the telescope. Class 100 air can be circulated around the telescope while the doors are closed. This is the scene in the battery lab, and here we see the facility where the batteries will be dropped to freezing and that temperature monitored to take on that charge. The batteries were taken back out to the pad last Friday and reinstalled Friday night, leading up to a test on Saturday morning to verify those connections and the health of the batteries, and then the payload bay doors were closed on Saturday night about 10:15 p.m. The launch team and the flight crew now are beginning the cabin leak checks, now with the access hatch of Discovery closed. And we continue toward an on-time liftoff this morning at 8:31 a.m. Eastern Time. At T-minus 1 hour, 3 minutes, 20 seconds and counting, this is Shuttle Launch Control.
And RCRE, OTC.
OTC, we copy.
This RCRE. Yeah, we want to support S-band to high power on 232, please. Go on 232.
GCSE going through 232. OTC, CL212.
Go ahead.
I need a reading off of panel 01 from the CDR.
CDR, OTC.
Go ahead.
Yeah, go ahead, ECL.
I need a reading on panel 01 for the cabin pressure.
Okay, we see about 14.6 here.
I copy, thank you.
SOTC?
Yeah, 659 through 662 complete.
Okay, you can pick up step 684 at this time.
Copy.
And GLS OTC.
Go ahead.
You can pick up GLS mainline activation by the clock.
Yes, sir. We copy.
This is shuttle launch control at T-minus 56 minutes and counting. The solid rocket booster test conductor has been asked to verify the chamber pressure in the solid rocket motors.
Still copy.
Transducers measure the pressure in the thrust chamber at the nozzle of the boosters. This information is used to tell the computer when to separate the solid rocket boosters in flight. All is continuing to go well with this morning's countdown. The flight crew is aboard the Space Shuttle Atlantis. The pre-flight alignment of the inertial measurement units has picked up and will be completed during the T-minus 20-minute built-in hold. The crew module closeout will be coming up in about the next 20 minutes. The Mila tracking station at KSC has now switched from low power to high power for the liftoff. Once Discovery lifts off from the launch pad, NASA tracking stations which furnish launch support will provide the air-to-ground voice, data, and telemetry. During launch, the Mila tracking station at KSC will follow the vehicle for 6.5 minutes. The Bermuda station will track until launch plus 11 minutes, and then the tracking and data relay satellite system will provide coverage beginning at the 11-minute mark and for the duration of the mission. During the second minute of flight, the Ponce de Leon Inlet tracking station north of the cave, located near New Smyrna Beach, becomes the primary communications link. During about a minute period when the signal at KSC is being attenuated by the reflective plume of the solid rocket boosters, this station becomes necessary. Overseas, NASA's tracking station at Dakar, Senegal is tracking from the east coast of Africa and would be called on for support in the event of an abort once around. At the end of the mission, on the approach to California for landing at Edwards Air Force Base, the Goldstone tracking station and the Oak Mountain tracking station at Vandenberg Air Force Base can track the shuttle during the terminal phase of the mission. The weather continues to be favorable here at KSC for a launch this morning. We do not have any significant technical issues in work, and at this time we do not see any constraints to a launch at 8:31 a.m. this morning. The launch period would extend until 2:43 this afternoon. However, our limitation for the crew on board Discovery would expire at 11 a.m. At T-minus 53 minutes, 20 seconds and counting, this is shuttle launch control.
OTC, CMQC. Go ahead. We had a line item 82 and it has been canceled. It appears to be a mileage problem. Copy. Go ahead, Randy.
This is shuttle launch control at T-minus 47 minutes, 15 seconds and counting. Cape weather confirms that the latest Gymsphere, the upper air wind balloon, has just been released to finalize our upper air wind data. Looking at our satellite picture from offshore, there are areas of scattered clouds over the ocean that will move inland and will go variable to broken occasionally, but this will not be a factor during the launch other than intermittently. The forecast continues to reflect generally scattered clouds over the launch site. Range Safety has recently told the NASA test director that their range safety checks of the safe and arm devices on the space shuttle have been completed, and that is satisfactory. And all is continuing to go well in this morning's countdown. There are no constraints to an 8:31 a.m. liftoff this morning. If the space shuttle lifts off on time, then Discovery's twin orbital maneuvering system pods will fire at 9:17 this morning to circularize the orbit at 380 statute miles. At about 10 a.m., the payload bay doors of Discovery will be opened. The major activity for the first day of flight will be to check out the remote manipulator arm, activate the protein crystal growth experiment, and to check out the contingency EVA suits, flight suits. Shortly after 7:30 tonight, the crew will go to bed. On flight day 2, the astronauts will begin their first full day in orbit shortly after 3:30 in the morning.
Roger that.
At about 7:45, astronaut Steve Hawley will lock the remote manipulator arm onto the telescope, and then the 4 latches that are holding the telescope into the payload bay will be released. At about 8:20 a.m., the umbilicals connecting the telescope with Discovery will be released, and Hawley will lift the telescope from its mounts in the payload bay. Then one of the significant milestones of the deployment will come at about 9 a.m. when the solar arrays will be unfurled. And if they do not unfurl properly, that is where Bruce McCandless and Kathy Sullivan have an option to do an EVA to attempt repairs. If all goes well, when the solar panels are deployed, then the crew will break for lunch and at around noon begin the operation to deploy the telescope's radio antennas. The next major milestone comes at 1:30 in the afternoon, when the telescope will be rotated into position for release with the nose pointing down toward Discovery's tail. And the final event will be at 1:54 p.m. when Steve Hawley is scheduled to release the Hubble Space Telescope from Discovery. The shuttle will then back off to a distance of about 45 miles so that the aperture door of the telescope can be opened without fear of contamination, and the telescope can be checked out. After the deployment is complete, the HST communications will be with the Space Telescope Operations Control Center on the ground at the Goddard Space Flight Center, which will be via the tracking and data relay satellites. Otherwise, repair and refurbishment missions are expected to be necessary every 3 to 5 years. The remaining days on orbit for STS-31 will be devoted to the protein crystal growth experiment, the radiation monitoring equipment experiment, a shuttle student involvement project, and the Air Force Maui Optical Site calibration tests. Next Sunday morning at 1:30 a.m., the astronauts will be awakened to begin their preparations for a return to Edwards Air Force Base. Shortly before 5 a.m., the shuttle's payload bay doors will be closed for the re-entry. The deorbit burn will occur at 9:31 a.m., and the end of the mission will be at 10:02 a.m. Eastern Time at Edwards Air Force Base. The launch countdown continuing on schedule for a launch now which is just over an hour away. At T-minus 42 minutes, 20 seconds and counting, this is shuttle launch control.
Yes, go.
Can you pick up SEP 737?
Copy and work. OTC, CL212.
Go ahead.
Okay, I can give you 725.
Copy that. CDR OTC, air to ground 1.
CDR, go ahead.
Okay, we can perform our cabin vent redundancy config at this time. On panel L2A1.
Roger.
Vent ISO switch closed until the vent ISO talkback shows closed.
That's complete.
And the vent switch open until the vent talkback shows open.
That's complete.
Copy. ECL OTC.
Go ahead.
Yeah, 746.
Okay, we're going to monitor that for a few more minutes.
Okay.
OTC, CL212.
Go ahead.
Okay, we can give you step 746 this time.
Okay. How about 747?
Okay, it'll be 0.008.
HC CDOTC. This is CHD. You ready for the captain's event? Oh, that's affirmed. Copy that. CDR OTC, air to ground.
Go ahead.
You want to open the captain's vent ISO valve and the klaxon and master alarms may occur in the next step.
Roger.
Panel L2A1, the vent ISO switch open until the vent ISO pump back shows open.
That's complete. And we have the klaxon.
And ECL.
I can verify step 751.
And CDR, verify.
This is shuttle launch control at T-minus 36 minutes and counting.
That's affirmative. It is decreasing.
The SRO, which is the Superintendent of Range Operations, has just informed the NASA Test Director that the range is ready for launch, meaning that the downrange shipping lanes are clear, that the booster splashdown area is clear, and that all of the Air Force Eastern Test Range downrange tracking stations are up and ready to support. The ground launch sequencer mainline computer program has been activated and is now actually processing data. This program will monitor various key commands and systems prior to assuming control of the countdown at the T-minus 9-minute and counting mark. The shuttle weather officer in the Cape Canaveral forecast facility will be giving Launch Director Bob Seek a briefing at the T-minus 25-minute mark in about 10 minutes. We've received word that the latest wind balloon, the Gymsphere, has completed its run at 56,700 feet, and that data is now being processed. Much of the activity over the last week has been associated with changing out Discovery's #1 auxiliary power unit, which was removed last Saturday and sent back to the vendor for analysis. A new one was on hand and ready for installation, and we have video of that unit being prepared for transportation to the launch pad.
Discovery Houston, SIMO air-to-ground voice checks, Eddie Reed.
The auxiliary power unit, which presented the problem, was found to
After that, MS's 1, 2, and 3.
have a chip in one of the valves that's involved with regulating the flow of hydrazine. Therefore, what we found was a one-time hardware problem
MS3.
and not an overall design or engineering concern. This is the replacement auxiliary power unit being prepared for transportation. In the back, there is the one that was taken out and was shipped back to the vendor for analysis.
Altimeter setting of 30.
That is the aft area of Discovery where the replacement auxiliary power unit will be installed, and adjacent is the external tank and the solid rocket boosters.
Now what we're working, manual right now is a single string for tack amps.
The replacement
We're planning on going
unit was transported to the pad on Saturday and was connected
possibility of a 3,000
on Sunday. Most of that work was completed in time to give most of the
basically all 3 tack
team the rest of the Easter Sunday period off.
primary tack amp back up again. We may yet declare banjo.
After the installation, the replacement auxiliary power unit was hot-fired, was run for a little over 5 minutes to verify that there would not be a repeat of the problem that we had before, and to give it the same amount of runtime as the other auxiliary power units which are on board Discovery. And that test went fine.
Okay, Steve, we copy.
And CDR OTC, air to ground 1.
This now is going into the aft area for the installation. In parallel with this activity, the payload bay doors of Discovery were closed and the batteries for the Hubble Space Telescope were back in the battery lab being charged. This procedure had not been done vertically before. It had been done in the hangars, So that procedure was modified with some contingency time built in to allow for any problems should they be encountered, this being a new approach. However, the change out and the retest went very well. Most of that contingency time was not used, and with the Hubble battery charging getting started a little bit earlier, then all things came together to make it possible to move up our launch date from the 25th to the 24th.
And that's the Northrop 2-3.
We're now at T-minus 31 minutes 50, T-minus 30 minutes 55 seconds and counting, leading toward an 8:31 a.m. liftoff this morning. This is Shuttle Launch Control.
Peter below SOTC.
Double left, good.
Can you verify anything on your CRTs? On G and 2 press.
Yeah, they're verified.
Copy. OTC, OVCC. Go ahead. Yes, sir. Op support setup 20. Side hatch closeout and white room configuration is complete. We're ready to clear the pad. Okay. Expect at 811. Copy that. OSC, OTC. C1C, go ahead. Okay, you want to pick up 774, please? 774 through 778 are complete. Copy that. OTC, Seattle. Go ahead. Yes, sir. Step 787 is complete. Copy. OTC, CCD. Go ahead. 768 complete. Copy. LVCC, OTC. ISL OTC. Sasha, go ahead. Are you ready for the next pre-flight brief? Yes, I am. EPD. EPD copy. OTC, EPD. Go ahead. I can give you step 790. Okay. CLS OTC. CLS 2 and 2. Yeah, you want to pick up 791 by the clock, please. Copy 791 by the clock.
OTC, CL212.
Go ahead.
I can give you step 807.
Copy that. CDR OTC, air to ground 1.
CDR CDR, go ahead.
Can you report your cabin press at this time, please?
The gauge looks like about 14.8.
Copy that. ACL.
Okay, on 809, I have 14.82.
Okay, CDR on the CRT-3. EFS system page 1. Report your cabin press, please.
And OTC CDR cabin press is 14.7 on the CRT.
Copy that. And CDR, at this time, you can close your cabin vent valves.
Didn't work. OTC CDR on both the vent ISO and vent are closed.
Copy that. ACL.
And I can give you 814.
Copy. PVD OTC.
This PVD, go ahead.
We're going to be performing steps 821 through 23.
Negative will be all not performed.
AFM OTC.
KFM, go ahead.
You can do your start check or door open indication status check at this time.
It worked.
The countdown clock will hold at T-minus 20 minutes in approximately 4 minutes.
OTC AFM.
Go ahead.
I can give you step 831.
Copy. All operator systems on channel 212. Verify your program software and report only if any discrepancies.
That's 031.41.
Thank you. ARPS OTC. ARPS OTC channel 212.
ARPS.
Yeah, you want to pick up step 838 and change the MTU test set to delay 0?
That's complete.
Thank you. EPS OTC.
Yes,
Can you verify 2 consecutive OC test concurrencies available?
that's verified.
Thank you.
This is shuttle launch control at T-minus 20 minutes, 30 seconds, and counting. We are preparing now to enter the T-minus 20-minute built-in hold. This hold will last for 10 minutes. During this period, the NASA test director will ask members of the launch team to verify that the proper software has been loaded aboard for the remainder of the countdown, and we'll get verification that the pre-flight inertial measurement unit alignment has been completed. Going into the hold now in 3, 2, 1, T-minus 20 minutes and holding for 10 minutes. The landing and recovery director has reported that the shuttle landing facility is ready and configured for launch and has verified that the booster recovery ships are on station and ready to support. The NASA test director is about to brief the launch team on recycle options during the remainder of the countdown. From now until T-minus 31 seconds, any of the console operators can ask that the countdown be held if a problem is detected. After T-minus 31 seconds, however, any unplanned hold would result in an automatic cutoff of the countdown and a recycle back to the T-minus 20-minute mark. The launch director has just been given an update on the weather. We continue to see mostly scattered clouds offshore, gradually moving onshore, and they are not expected to be a constraint. As they move onshore and into the area, they are being evaluated by Dan Brandenstein in the shuttle training aircraft as he makes approaches to the shuttle landing facility. Overseas, Banjul weather is acceptable, reporting clouds 12,000 scattered, 20,000 thin broken, visibility 6, and northeasterly winds 10 to 15.
KBFX active on 212. HTD.
Here at KSC, our winds running mostly from the east at 10 to 12, and the status board at the Cape Canaveral forecast facility reflecting shuttle weather constraints is all green at this time. At T-minus 20 minutes and holding, this is shuttle launch control.
SRO NTD 212. SRO NTD 212. NTD, this is GOS. I see him coming in weak. We're working the problem. Copy.
NTD CGLS on 212.
Go ahead, John.
Yes, sir, the countdown clock will start at 12:01 GMT.
Copy. OTC PD. Go ahead. Did I get a CMQC on 151?
CMQC OTC.
The CMQC, go ahead.
Yeah, EPD OTC.
Go ahead.
What are you doing?
Get it for the fuel cell load sharing adjust.
Okay, yeah, 151 QC.
Stop looking at it.
Copy.
OTC CFCP.
Go ahead.
Yeah, can we get a CMQC on 153?
Same thing?
That's fine for our purge.
Okay. CMQC.
Copy 153. OTC, Seattle.
Go ahead. Yes, sir. We also need a CMQC on 145 for recorder activation later on.
CMQC.
Copy, 145. SRO NTD 212.
NTD RSO, read you loud and clear on 212. 212.
RSO NTD 212.
NTD
RSO NTD, do you copy on 212? OTC, TP, go ahead. Can I speak to COOS on 161?
COOS OTC.
Yeah, go ahead.
Yeah, can you go 161 with TPE, please?
Yeah, going to 161. NTD safety 212. Go ahead, sir. Yes, sir, I can give you step 966, closeout crew at AB11. Have you got any words on step 798? STM NTD. STM NTD 212.
STM, go ahead.
You have a verification of 798.
We've got the CCF clear. We're still waiting on the LDA.
Copy. This is NTD on 212 and 232 conducting the T-minus 20-minute briefing. The launch window opens at 12:31 GMT and closes at 18:43 GMT. A second launch attempt is possible if a recycle occurs. There are 3 COLAs for today. COLA 1 opens at 12:58:30 GMT and closes at 12:59:30 GMT. COLA 2 starts at 14:32 GMT and ends at 14:37:30 GMT. COLA number 3 opens at 16:12 GMT and closes at 16:13 GMT. If a hold is requested and issued between T-minus 9 minutes and T-minus 31 seconds, the countdown clock will be restarted upon successful resolution of the problem without a go survey made of all elements. PLT at T-minus 5 minutes perform APU start upon command of OTC only.
CLT copies.
CDR, the pad egress system is nominal and the evacuation helipad is 8.
Okay, we copy 8, thank you.
Fine room launch team, disable telephone ringers at this time. Ingress and egress of the fine room will not be allowed after resuming the count at T-minus 20 minutes until after launch or flight crew egress if a recycle occurs. If an extended hold is required at T-minus 9 minutes, limited fine room access will be allowed. All personnel bear in mind that critical post-launch operations will be in progress after a successful launch, so keep fine room activities and noise to a minimum. Are there any questions? That concludes the briefing. Flight NTD. Houston Flight NTD 212. Houston Flight NTD, air to ground 1.
Okay, NTD Flight 212.
Okay, step 897A, you can proceed with transmission of your variable ascent parameters.
Hey, welcome.
And flight, can you verify that you're ready?
That's correct, sir.
Houston Flight NTD.
This flight go.
Step 898, can you verify ready to resume the count in 20 minutes?
Okay, stand by 1 second, NTD. NTD Flight is go.
Understand. The countdown clock will start at T-minus 20 minutes in 2 minutes.
OTC CTNC, go. I can report step 897. IMU pre-flight alignment is complete. Ready for transition to off 1. Off transition must occur within 10 minutes. Your GMT time there is 11:58. 11:58, copy. And I can also report completion on steps 899 and 900. Copy that.
NTD copy.
NTD STM 212.
Go ahead, STM.
Okay, step 794. 7 run to this OTC. After transition to Ops 101, discontinue all LDB PMU reads for remainder of count.
Safety console in today. Safety console 798 is complete. Copy.
This is shuttle launch control at T-minus 20 minutes and holding. We are just about 1 minute away from picking up the countdown at the T-minus 20-minute mark.
Yeah, CMKC.
As we come out of the hold, Discovery's onboard computers will transition into the terminal countdown configuration, and we will dump the computer memory of one of the 4 primary computers so that we can look at the data and make sure that the Ops 101 program, which is the primary program, has been stored properly and that there are no unexpected results.
Copy that.
Taking up the count now in about 20 seconds.
I copy that. Space 966 also.
Again, we're still aiming toward an 8:31 a.m. liftoff. We have no constraints with the shuttle or weatherwise. Picking up now in 5, 4, 3, 2, 1. T-minus 20 minutes and counting.
SCP OTC.
Purge of Discovery's 3 fuel cells is now underway. The data processing system engineer has confirmed that the onboard computers are in the process of making the transition to the terminal countdown configuration. We do have 3 COLAs today during the period, which extends from 8:31 to 2:43. There would be a collision avoidance quotient that would begin at 8:58:30 this morning and run for 1 minute. There would be another one at 10:32 this morning, which would last for 5.5 minutes, and another one at 12:12 this afternoon, which would last for 1 minute. That last one, however, would be academic in light of the fact that the crew time in the cockpit of Discovery would expire at 11 a.m.
CEPP OTC here to ground 1.
All activity continues on schedule as we proceed toward the next hold at T-minus 9 minutes. The primary ascent software is now in the Ops 101 mode, which is the primary launch program, and Commander Shriver will now configure the backup flight system computer to match that configuration. T-minus 18 minutes, 20 seconds and counting.
NPD STM 212.
Go ahead, STM.
Step 916. Will that be performed or not performed, sir?
That's not performed.
Copy.
OTC, CDR, and PFS is an Ops 1, no unexpected messages.
Copy that, thank you. And PLT, OTC.
Go ahead, Sam.
Okay, configure pass and VFS horizontal sit displays per your checklist, please.
Commander Shriver has reported that the backup flight system is now in the proper mode, and we just saw astronaut Dan Brandenstein flying the shuttle training aircraft, doing the weather reconnaissance and assessing the conditions at the shuttle landing facility in the event of a return to launch site abort. He's reporting that data to support astronaut Ken Reichler and astronaut Jim Weatherby here in the firing room. T-minus 17 minutes and counting.
Go ahead.
The BFS pre-flight uplink load is complete.
I copy. CVFS.
CVFS copies.
Dumping of the Ops 101 program stored in the memory of one of the 4 redundant general purpose computers is now underway. That will take about 7 minutes to complete. Engineers will be examining that data for anything that would miscompare.
Go ahead, PLT.
Okay, horizontal fit. Yeah, Stan, horizontal fit config is complete, and we verified the OHM's interconnect config is also verified.
Okay, copy that.
Pilot Charlie Bolden has been in the process of configuring the cockpit switches for launch, and he's reporting that most of that configuration is complete. The airframe engineer is checking all of the critical movable aerosurface driver currents and is positioning all the hydraulic systems for activation.
NTD SRO, go ahead, sir.
969 KSC area is clear for launch.
Roger, copy.
OTC PLT, MPS helium reconfig is complete.
Copy that. MPS OTC.
MPS, go.
Can you verify 945, 946,
Verified.
and 47?
Yeah, yes, sir.
Copy that. Double OS.
Go ahead.
Okay, configuring arms RCS cross feed for flight.
At this time, yes.
Copy.
Pilot Charlie Bolden has reported that the helium system reconfiguration has been completed. This opens helium isolation valves necessary for the in-flight purges of the engines.
Checking, sir.
Water levels in the water spray boilers are now being checked, and they are being verified to be sufficient for the mission. The NASA test director has asked Houston Flight to send their pre-flight uplink command to the orbiter's backup flight system. These loads are sent from the Mila tracking station here at KSC and put the fifth general purpose computer in the proper configuration for launch.
NTD SRO 212.
Go ahead.
Yes, sir. Page 813, step 0965, normal track.
Copy.
Configuration of the cross-feed valves between the orbital maneuvering system and the reaction control system propellant tanks is being performed. The orbiter test conductor has asked pilot Charlie Bolden to report the quantities in the reaction control system propellant tanks. Meanwhile, the booster test conductor has been asked to start the gaseous nitrogen purge of the aft skirts. This flow of inert gas ensures that no explosive or flammable gases can accumulate in the bottom of the solid rocket boosters prior to their ignition. We're at the point now where all non-essential personnel are being cleared from the launch danger area. The white room has been closed out for flight, and the closeout crew has departed back to the roadblock.
MTD STM 212. Step 986, sir. Copy. And FCP OTC here to ground 1.
FCP?
Yeah, your fuel cell purge complete?
Will be shortly.
Copy. Countdown clock will hold at T-minus 9 minutes and 4 minutes.
OTC, CFCP.
Go ahead.
Our fuel cell purge is complete and we're ready for fuel cell load adjustment.
Okay, EPD and ECL and FCP, adjust your fuel cell loads for the Ds.
EPD copy. FCP copies.
ECL copies. OTC CVFS.
Go ahead.
T-minus 20 minutes, UTC dump is complete.
Copy that. CMQC is 979. Copy 979.
T-minus 12 minutes and counting, we've received word from White Sands that the weather reconnaissance aircraft there has advised that with the wind that they're seeing, there is still ample margin out there to cover any contingency in the event that we should have an abort once around. He has reported his observations to the chairman of the mission management team, Brewster Shaw, and Brewster has determined that weather at White Sands is go for launch. We've also received a verification that all of the contingency support is ready and that the Aircraft and emergency teams are on station to support the launch today.
Copy that.
The T-minus 20-minute dump of the orbiter general purpose computer memory has been
Copy.
completed. We have no unexpected errors in that report. Now T-minus 11 minutes and counting.
Load adjust is complete. Copy that. ECL. ECL OTC.
Go ahead.
Yeah, can you agree with fuel fill? EPD.
That's affirmative.
Copy. All personnel on channel 212, this OTC. Discontinue all non-mandatory LDB traffic for remainder of count.
T-minus 10 minutes and counting. About 1 minute now from the last planned built-in hold in the STS-31 launch countdown this morning. The flow rate of the conditioned air fed into the orbiter's payload bay is being reduced and will be verified at about 180 pounds per minute, which is the figure desired for launch. Standing by now to go into the hold at T-minus 9, 3, 2, 1, T-minus 9 minutes and holding for 10 minutes. We will emerge from this hold at 8:22 Eastern Time. When the countdown resumes, the ground launch sequencer will be in control. The master computer program will issue the commands to perform all of the final critical tasks required to put the vehicle in its launch configuration. During that time, it will be monitoring as many as 1,000 different parameters in that last 9 minutes to make sure that they do not fall out of any predetermined limits that the launch team calls red lines.
DVD, go ahead.
All personnel in Firing Room 1 have now switched over to the same communications channel, and they will be staying on that through launch.
This is NTD on 212, taking a status check for launch. Say go, no go for launch. OTC? Go. TVC? Go. TTC? Go. LPS? Go. Flight? Houston flight, NTD. Nala? Nala, NTD. STM? STM, let's go. Safety
Would it be legal to call my old lady?
Now about 2 minutes into the T-minus 9-minute built-in hold. We'll go now to Mission Control in Houston for a readiness statement and also to the Space Telescope Operations Control Center at Goddard. They will report their readiness. Going now to Mission Control in Houston.
This is Mission Control Houston. Flight controllers in the Figure 1 room are ready for launch. The flight director for Ascent, Von Dittemore, just polled the room, and all positions reported they will be go for coming out of the T-minus 9-minute hold. One slight change to this morning's plans for launch. Ben Guerir will be designated as the prime transatlantic landing site with Banjul as backup due to a problem with the primary TACAN system at Banjul. The secondary TACAN system is operational, but since weather is good at both sites, we will be choosing Ben Guerir as the prime transatlantic landing site this morning. No other systems problems are reported, and all positions in Mission Control are standing by for launch. This is Mission Control Houston. We'll hand over now to Hubble Space Telescope operations at Goddard.
Them wheels, channel 118 X-ray.
This is Hubble Telescope Control Greenbelt. The Director of Orbital Verification, Mike Harrington, has confirmed that all control team positions here at the Space Telescope Operations Control Center in Maryland and the support team at the Huntsville Operations Support Center in Alabama are ready to support today's launch of the Hubble Space Telescope. Approximately 3 hours ago, the crew configured switches aboard the orbiter to provide essential power to 3 telescope systems. The telescope's receivers were powered to ensure that they are warm and on frequency to receive initial commands from the control center following launch. Heaters for the rate sensing units were powered to maintain the gyros at a stable temperature, and power was applied to the fixed head star tracker shutters to ensure that they remain closed during launch. Otherwise, the telescope is essentially powered down in Discovery's cargo bay and ready for launch. Beginning approximately 4.5 hours after launch, controllers here will begin sending commands to systematically activate the telescope systems in preparation for tomorrow's scheduled deployment. Again, all is ready here in the control center at Goddard Space Flight Center, Greenbelt, Maryland, and at the support center at the Marshall Space Flight Center in Huntsville, Alabama, for today's launch of the Hubble Space Telescope. At T-minus 9 minutes and holding, this is Hubble Telescope Control Greenbelt, returning now to the Launch Control Center.
This is Shuttle Launch Control in Firing Room 1 of the Launch Control Center at KSC, where we have approximately 5 minutes remaining in the T-minus 9 minute built-in hold. Several milestones remain between now and launch. As we come out of the hold, the ground launch sequencer will take over control and issue commands for the final critical task and monitor the hundreds of vehicle measurements that are coming in during the final 9 minutes. At T-minus 7 minutes 30 seconds, the orbiter access arm retraction will be performed.
No constrained explained condition.
And at T-minus 5 minutes, pilot Charlie Bolden will start up the orbiter's auxiliary power units.
SMS D as in dog.
A gimbal check of the orbiter's aerosurfaces will occur at T-minus 3 minutes 55 seconds. And switch over to internal power occurs at T-minus 3 minutes 30 seconds. And then the orbiter's main engines will be gimbaled or moved at the T-minus 3 minute 25 second mark. LOX tank pressurization and retraction of the GOX vent hood will start at T-minus 2 minutes 55 seconds, and the liquid hydrogen tank will be pressurized for flight at T-minus 1 minute 57 seconds.
Launch Director, with that, the team is ready to proceed. That's step 1016.
Okay, I'll conduct my poll at this time. Payload Operations Director.
Launch Director, payloads are go.
Copy, Engineering Director.
Engineering is go.
Copy, Safety and Quality Director.
Safety and quality's go, boss.
Copy, Cape Weather.
No weather launch constraints violated. Launch wind forecast from 090 degrees at 10 knots.
I copy, Operations Manager.
Bob, we have no constraints, and you are go to proceed with the launch.
Copy, thank you, sir. Discovery Launch Director. Air to ground.
Discovery, go ahead.
Okay, well, at the risk of being repetitious, we're here again, and everything looks good. Shuttle, ground systems, and the Hubble, and we believe the universe is still go. So we hope we can get you up there to take a look at it today. Have a good one.
Okay, we sure do. Thank you very much. Looks like it's been a good countdown here.
Yes, sir, and MTD, you have go to proceed.
I understand, thank you. Flight, ISL, RPS, NTD.
This flight.
ISL.
This is ISL.
JRPS.
JRPS.
Okay, step 1012, you can activate recorders. Copy.
TVD OTC.
This DVD, go ahead.
Yeah, we have a payload bay purge rate set for launch at this time.
As confirmed, we just completed. It's stable at 178.
Copy that.
With it not performed on step 1009.
Copy that.
Entity flight recorders have been activated.
Copy. Countdown clock will start in 2 minutes. ISL, did you copy that recorders are active?
NTD, CNSE.
Go ahead, CNSE.
Yeah, overheard changing tail sights to 118 X-ray.
That's firm. And we're now Ben Greer.
And they changed those sun wheels yet?
That's firm.
Copy.
1 minute and 30 seconds from picking up the countdown at T-9, where we will press on toward the handoff of the ground launch sequencer to Discovery. The onboard computers will then start their own automatic sequence, and the final commands will come at T-minus 10 seconds to provide the concurrence for a go for main engine start. The engine start will occur at T-minus 6.6 seconds and solid rocket booster ignition at T0. The orbiter's computers will issue the commands to start, and the ground launch sequencer will concur. 45 seconds now to picking up the countdown. "30 seconds away from picking up at T-9. Nothing is reported amiss, and we are go for picking up the count in 10 seconds.
Countdown clock will resume on my mark. 5, 4, 3, 2, 1, mark. ULS auto sequence has been initiated.
Now into the final phase of this morning's launch countdown with the initiation of the ground launch sequencer. Standing by now for a request from the orbiter test conductor to Houston Flight to send stored program commands, which are the final update on the antenna alignment.
PLT was that, OTC was that for the PLT?
That's affirmative. Configure fuel cell essential bus source switches, please.
That's in work, Stan.
Thank you.
OTC PLT, essential bus connection is complete.
Copy that, thank you.
Next significant event coming very shortly here, with the orbiter crew access arm being retracted away from the vehicle into the launch configuration. This arm can be re-extended in less than half a minute if that's necessary. T-minus 7 minutes, 30 seconds and counting.
ULS's go for orbiter access arm retract.
In about 45 seconds, the orbiter test conductor will give pilot Charlie Bolden a go to perform the auxiliary power unit pre-start. Bolden will configure switches in the cockpit to put the APUs in the ready to start configuration. The APUs will be started at T-minus 5 minutes. Go for APU pre-start will come in about 10 seconds.
You want to start your APU hydraulic tip chart recorders, please. Recorder started. And PLT OTC.
Go ahead.
You can perform your APU pre-start, please.
That's in work.
The APUs provide hydraulic power to the orbiter. Standing by for confirmation that the APU pre-start is complete.
Pre-start's complete. 3 great talkbacks.
Thank you, Charlie.
Pilot Bolden reporting back that the pre-start operations are complete. T-minus 5 minutes 30 seconds. Mission Control has transmitted the signal to start the flight recorders. The 2 recorders will collect measurements of the shuttle system's performance during the flight for playback later after the vehicle is in orbit. Coming up on T-minus 5 minutes and counting.
TLS is go for orbiter APU start.
And we have a go for APU start.
APUs, please.
That's in work, Stanley.
And CDR OTC.
Go ahead.
You can reconfigure heaters, please.
Commander Schreiber asked to reconfigure the orbiter heaters. He'll report when that's complete.
Heaters are reconfigured.
Thank you.
The ground launch sequencer has terminated liquid oxygen replenish to the external tank and is now initiating the LOX drain back.
And OTC, PLT, APU start is complete, and so far so good.
There are the good words. 3 APUs in good health. About to start a profile test. Profile test of the orbiter's aero surfaces. The orbiter flight control surfaces are being moved through a pre-programmed pattern, and we'll have a gimbling of the main engines, which will follow. Final purge sequence of the main engines is in work. We're now transferring to internal power and switching off the orbiter's ground power supply. At this point, Discovery is being powered by the onboard fuel cells. T-minus 3 minutes and counting.
TLS is go for ET-LO2 pressurization.
Go for pressurizing the external tank. All systems are go for launch.
OTC 212.
Go ahead, OTC.
Okay, clear caution and warning memory and verify no unexpected errors.
Okay, we have no caution and warning annunciation, Stan. That's
Okay.
complete.
Thank you, Charlie.
Standing by now, here is the retraction of the gaseous oxygen vent hood. The gimbling of the main engines is complete, and the aero surfaces have been verified that they are positioned for launch. The external tank now is reported to be at flight pressure.
OTC 212. Close and lock your visors and initiate your O2 flow, and you all have a good trip.
Roger that. 10 work.
TLS is go for ET-LH2 pressurization.
Bringing the LH2 pressurization up to flight levels. 90 seconds away from launch now.
1 minute, 30 seconds.
And the LH2 tank now reported at flight pressure. Both tanks, liquid and oxygen, now ready to flow propellants. Sound suppression water system is now being armed, which will flow water onto the mobile launcher platform at the rate of 900,000 gallons a minute, beginning at T-minus 16 seconds. The heaters on the booster joints are now being turned off. The orbiter computers have positioned the vent doors to the launch configuration. Standing by now for a go for auto sequence start. T-minus 33.
Countdown clock will hold at T-minus 31 seconds due to failure.
We've had a hold. We do not know at this time what the problem is. We'll be standing by for word, but the clock is holding at T-minus 31 seconds due to a system failure.
And NTDSD, it's the LO2 outboard fill and drain valve. NTD is CMPL. Go ahead. It's LCC MTS 8. And PV9 outboard fill and drain closed power is off. It should be on. A recommendation? And NTD, that we're in a no-go situation. We should have our open power, and we do not. Or excuse me, our closed power. SP. And MTS, can we verify that the valve is closed? Negative. We right now show a open position. We cannot verify the valve is closed.
SP, this is MTS.
Go MTS.
The way that LCC reads, if we have the closed power on and the open position off, we can cycle one time and try to pick up the closed position, but we never picked up the closed power.
Okay, and MTS, we have a message that we were blocked by a prerequisite sequence, GCL 18.
What has happened is the ground launch sequencer would not hand off to the orbiter's computers to complete the count because the liquid oxygen fill and drain valve was showing off when it should be on. An analysis of the problem has begun.
We've been holding 2 minutes.
SPE, this is CMTS. We're going to make an attempt to cursor that valve closed. We've got the prereq set off. If this works, we should be in good shape.
I copy. Proceed.
Can work.
We have 7 minutes of runtime available on the auxiliary power units. We've been holding now about 2 minutes and 20 seconds.
NTD, this is CMTS. The valve is closed. We're go.
There's the confirmation that we have successfully
You're in the
recycled.
the pickup terminal sequence, MPS.
That's affirmative, so we're go. We're in good shape.
Okay, you have a go to proceed. GLS, pick up the count immediately.
I copy. Mark. GLS is go for auto sequence start.
We are go for start.
25.
Booster hydraulic power units have started.
20.
Sound suppression water system has started.
15.
T-minus 13 seconds.
10.
T-minus 10, go for main engine start. We are go for main engine start. T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Mission Control, Houston.
Roll program.
Roger, roll, Discovery.
The roll maneuver puts the vehicle in the proper launch plane. Guidance officer confirms a good roll maneuver. Engines now throttling back. The throttle down maneuver assists in reducing the aerodynamic loads on Discovery as it passes through the area of maximum dynamic pressure. Velocity now 1,200 feet per second. Discovery downrange 3 nautical miles.
Discovery, go at throttle up.
All 3 engines now throttled back up.
Go throttle up.
Engines at 104%. The go at throttle up call signifies that all systems are performing well. All 3 auxiliary power units look good. Discovery's velocity now 2,300 feet per second and is downrange 8 nautical miles. Standing by for SRB separation. And both solid rocket boosters have separated. Discovery's velocity now 4,300 feet per second at a downrange distance of 35 nautical miles. Booster officer reports all 3 engines stable at 104% performance.
Discovery Houston, performance is nominal. And Discovery, 2-engine Ben Guerrier.
The 2-engine Ben Guerrier call means that Discovery could reach the transatlantic abort site at Ben Guerrier on 2 engines if it were necessary.
Copy, nominal performance, 2-engine Ben.
Velocity now 5,000 feet per second. Discovery 60 nautical miles away from the launch site. All systems continuing to perform well aboard Discovery. Velocity now is 6,200 feet per second. Downrange 100 nautical miles. The Environmental Systems Officer reports the FES is operating well. That is the flash evaporator system that provides cooling to Discovery's systems.
Discovery Houston, negative return, press to ATO, select Banjul.
Negative return, press to ATO.
That last call means that Discovery cannot return to the launch site at Kennedy. However, enough energy has been achieved to reach a safe orbit on 2 engines should one shut down, and Discovery could also reach the backup transatlantic abort site at Banjul if that were necessary. All 3 engines are stable at 104%. Auxiliary power units all performing well. Discovery's velocity is 8,400 feet per second at a downrange distance of 175 nautical miles.
Discovery, press to MECO.
Press to MECO.
The press to MECO call signifies that Discovery could make the main engine cutoff targets.
Discovery, Droop Banjul 109.
Droop 109.
And that last call means that Discovery could reach the Banjul transatlantic site on 1 engine at 109%. All 3 engines still looking good. Discovery's velocity 12,000 feet per second. Downrange range 290 nautical miles at an altitude of 60 nautical miles. Guidance officer confirms that navigation is good.
Discovery, single engine Banjul 104.
Single engine Banjul 104.
Booster officer reports all 3 engines stable.
Houston, single engine press 104.
The single engine press call means that Discovery could make it to main engine cutoff targets on 1 engine at 104%. Discovery's velocity now 16,000 feet per second at an altitude of 58 nautical miles, downrange 435 nautical miles.
Discovery, late call, single engine press 104.
Roger. Fuel cell pH, we expected.
Discovery Houston, concur, no action on fuel cell pH.
No action is required, no impact on that pH message. That message was expected during this phase of the launch. Velocity now 19,000 feet per second. 3 engines throttling back now to maintain the 3G limits on the vehicle. Discovery is 580 miles away from Kennedy at an altitude of 56 nautical miles. We are standing by for main engine cutoff at 8 minutes 32 seconds mission elapsed time.
Good, Nico. Looks nominal from here.
And the booster officer also confirms a nominal main engine cutoff.
Discovery, we see ET-SEP. Nominal MECO, ohms 1 is not required.
The booster officer has also confirmed.
No ohms 1 required.
This is mission control. The booster officer confirms good separation from the external tank, and the flight dynamics officer confirms good performance on both phases of the ascent. No orbital maneuvering systems 1 burn is required.
Discovery Houston, for info, we've had some problems out of White Sands, but we anticipate a nominal handover to TDRS at 11 plus 30.
And Houston, we copy, and we had left L3A tail off during the +5 second dump.
Roger that, Discovery. We see it. No action for you now. We're still evaluating.
This is Mission Control. The ground control officer does not expect any loss of communications capability with the crew. We will be handing over to the tracking data relay satellite at about 11.5 minutes mission elapsed time. There have been some minor problems at the White Sands ground station, but they expect no particular impact from that. Booster officer reports that we see data indicating the main propulsion system dump is in progress. This procedure vents any remaining fuel or gases that may have resided in the engines at the end of their burn, just to make sure that those gases are vented out of the system and not present any problems for the remainder of the mission.
Discovery Houston.
Discovery, we're standing by. Go ahead.
Roger that, alarm. We're back with you through TDRS. Expect nominal ohms 2, anticipated delta V 4, 9, or 5.
Okay, we copy and standing by on your go for APU shutdown.
Roger that, Discovery. Stand by. Discovery Houston, go for APU shutdown.
Roger.
This is Mission Control. The crew has received the go to shut down the auxiliary power units. And they've been informed also that the normal Orbital Maneuvering Systems 2 burn will be done on time, which is scheduled for 42 minutes 39 seconds mission elapsed time. Change in velocity will be 495 feet per second, and that burn will put Discovery in an orbit of 330 by 310 nautical miles. This is Mission Control. Mechanical Systems Officer reports that the APU shutdown was normal, that the procedure looked good, and the configuration of the auxiliary power units looks good. This is Mission Control. The MAX officer reports indications that the external tank doors are closing aboard Discovery. Crew is right on time, following through the post-insertion timeline, or the post-ascent checklist, and at about 50 minutes mission elapsed time, just short of an hour, they will begin procedures in the post-insertion timeline. MAX officer confirms that the external tank doors are closed and latched.
Discovery Houston, while you're on the way to Attitude, if you've got a spare moment, we'd appreciate a debris report.
Okay, Steve, stand by one. Houston Discovery, for debris on the way uphill, right in the about from a minute and a half to 2, Charlie and I noticed several flecks of things impacted the forward windscreen. They seem to be pretty soft and just leave little streaks. SRB SEP put a pretty good little cloud on all the windows. And here at Vacuum Inerting Terminate, we see lots of ice particles, but that's all normal. And between SRB SEP and MECA, we didn't really see that much debris that we can recall.
Okay, roger that, Discovery. Appreciate the report.
This is Mission Control. A guidance officer has reported that Discovery has almost completed the maneuver to the position for the Orbital Maneuvering Systems 2 burn. That burn is scheduled about 16 minutes from now at 42 minutes mission elapsed time. And that OMS burn will have a change in velocity of 495 feet per second and will raise the low point of Discovery's orbit to 310 nautical miles.
Discovery Houston, we see you in burn attitude and your targets look good.
Roger that, Houston. Hang on, Houston, Discovery, we see the tank and burn attitude down below us. It looks like it's straight down below us between us and Africa.
Roger that, Lauren, we copy, and about how far away do you think it is?
On the long axis, it would probably be about a 6 or 7 mil radius on the coax.
Roger that. Thank you very much.
is Mission Control. The guidance officer has seen the data indicating that Discovery is in the proper position for the OMS 2 burn. And Commander Lauren Shriver was discussing with Capcom Steve Oswald that the crew could see the external tank below them on its way to the impact area.
And Houston, Discovery, are you still with us?
That's affirmative, Discovery. You're loud and clear.
Okay, as we've been coasting here, we've just been watching the external tank tumble, I don't know, 4 or 5 times since we called you last.
Roger that. Must be a beautiful view. Discovery Houston with some words on your burn.
Go ahead.
Roger, Lawrence, since we lost L3A, if you should lose an engine during the OMS 2 burn, an OMS engine, we want you to terminate the burn at an HP of 85.
Okay, we copy.
This is Mission Control. That last note given to the crew refers to the small reaction control jet number L3A, which failed off shortly after the ascent phase was completed. Propulsion officer thinks that was due to a valve failure, perhaps in the oxygen valve system of that small RCS jet. Therefore, the crew's just been given a little note to change their procedure card. If during the upcoming Orbital Maneuvering Systems 2 burn, they should have an OMS engine failure, they would terminate the burn at an altitude, perigee altitude of 85 nautical miles in order to give flight controllers time to assess the situation and see what action should be taken at that point. We'll be coming up in about 2.5 minutes on the time of ignition for the OMS 2 burn. Once again, that's at 42 minutes, 36 seconds mission elapsed time. Delta velocity for the burn is 495 feet per second. Should raise the perigee of Discovery's orbit, or the low point of Discovery's orbit, to 310 nautical miles, resulting in a final orbit of 330 by 310 nautical miles. This is Mission Control. This is Mission Control. The propulsion officer reports that he sees data indicating that all the systems are in the proper configuration for the burn.
And Houston, Discovery, just information, the telescope remained powered up through ascent. We thought you'd like to know that.
Roger that, Discovery. That's good news. Thanks for the words. And Discovery Houston, your targets look good and your OMS configuration is good for the burn.
Roger that.
This is Mission Control. The propulsion officer reports seeing the OMS 2 burn begin and 2 good engines. Looking good so far.
Discovery Houston, we're going to lose you here in about a minute on the East Tidris. Burn's looking good so far. We'll see you on the west side at 51 minutes MET.
So we copy 51 minutes.
This is Mission Control. We've gone out of voice and data contact with the crew through the Tidris East. In about 3.5 minutes, we'll pick up communications again on the Tracking Data Relay Satellite West. As we went LOS, the OMS 2 burn was in progress and looking good, and we should have confirmation of the completion of that burn when we talk to the crew again. This is Mission Control.
Discovery Houston, back with you on the West Tidris. We see a good burn down here, 331 by 311. And your ohms configuration looks good.
Okay, we concur with that. We held off the gimbal check until we got back with you. We're ready to start that now.
Roger that, Lauren. We're standing by. You have a go for the gimbal check.
This is Mission Control. The propulsion systems officer reported a good ohms 2 burn and good post-burn configuration. Flight dynamics officer shows that Discovery's orbit is now 331 by 311 nautical miles, and the flight dynamics officer described that as looking super. This is Mission Control. The crew is proceeding now into the post-insertion timeline, and we'll be coming up here in a few minutes on the reconfiguration of the data processing system. The general purpose computers will be taken over to the Ops 2 software. That's for on-orbit operations. This is Mission Control. The Data Processing Systems Officer has reported that he sees the crew working the procedures for the reconfiguration of the data processing system, taking the general purpose computers over to the on-orbit software that's called OPS2. And the MAX officer reports that he sees the mission specialist crew members in the procedures to configure the aft control station at the rear of the flight deck of Discovery.
Discovery Houston, just to let you know we're still here. We see an OPS2 and looking good.
Roger that, Steve.